Hi, this is Calandra. Welcome to Week 1, Part 2 of Calandra and Nino's College Algebra Cohort. Today I'm going to go over with you how to solve linear equations, how to solve rational equations, and then we'll look at some application problems where we will be using these techniques. Previously we were working with expressions. With an expression there's no equal sign, so we can only simplify an expression. However, now we're going to be working with equations. When there's an equation, there's going to be an equal sign, and that means we're going to have to solve for a variable. So think of the two sides of an equation like a balance scale, and we have a little visual there for you. Whatever you do to one side of the balance or the equation, you have to do to the other side, so that way you keep the two sides balanced. So that's going to be the key to keep in mind when you're solving any type of equation. A linear equation is any equation that can be simplified to be of the form mx plus b equal to 0, where m and b are real numbers. So if we have an equation that can be simplified to be in that form, so x is the only variable and m and b are just numbers, then these are the steps that we're going to use to solve the linear equation. First, we want to combine like terms on each side of the equation, if there are any. Make sure you keep order of operations in mind. Secondly, get the variables on one side of the equation and numbers on the other side of the equation. Lastly, combine like terms again, and then you want to multiply or divide to isolate your variable. Typically it's x, but you may be dealing with other variables as well. Okay, so let's go through these two examples, or several examples, to illustrate solving linear equations. Okay, so for part A, my first step is to combine like terms on either side of the equation if there are any. Well, they're not. 5x plus 6 are not like terms. So next, we need to get all the variables on one side and the numbers on the other. So I'm going to get my variables over to the left. So to do that, that means I need to subtract 5x on the right side. But keeping in mind that equal sign is like a balance, I need to subtract 5x on the left also. So now I'm adding these together. 3x minus 5x is negative 2x. Bring down the equal sign. The 5x is canceled out and we're only left with 6. So now our last step is to get x by itself. Since negative 2 is being multiplied by x, we have to do the opposite operation. So that'll be to divide by negative 2. Keeping in mind our balance, we also have to divide the right side by negative 2 as well. So once we do that, we end up with x is equal to negative 3. And that would be our answer. Okay, for part B, my first step is to combine like terms on each side of the equation. Okay, well on the right side of the equation, I see that I have two x's. I can't combine them yet because, remembering order of operations, we need to multiply that 5 by everything inside of the parentheses. So we need to use the distributive property. So 5 times 7 gives us 35, minus 5 times x is 5x. We bring down that minus 2x, and all of this is still equal to 9 minus 6x. Okay, now I'm going to combine my like terms, negative 5x minus 2x. Okay, so we're just bringing down the 35. Combine your coefficients to get a negative 7x. That's equal to 9 minus 6x. Okay, so now I want to get my variables on one side, my numbers on the other side. So it doesn't matter which side you put your variables or your numbers, your final answer will be the same. I'm going to move my variables to the left. So that means I'm going to need to add 6x to both sides. And if I'm going to get my numbers on the right, that means I need to get rid of this 35. So the opposite of a positive 35, we're going to subtract it. So we're going to subtract 35 from both sides. So now we need to write what we're left with. Okay, making sure to bring down the equal sign to keep everything lined up properly. Okay, 35 minus 35 is 0. Negative 7x plus 6x is a negative x. You can put that negative 1 there if you need that reminder. Remember, when there's no number in front of the variable, there's an understood 1 that's there. 9 minus 35 is going to give us a negative 26. And then the 6x's cancel out. Okay, well, we don't have x by itself yet because we have that negative there. So what do we do to get rid of the negative? Well, you can think of it as dividing both sides by negative 1 or multiplying both sides by negative 1. So we end up with our final answer of x is equal to a positive 26. Okay, going on to part C. Okay, well, I think we all know the thing that's making that look hard is that there are fractions involved. So I have a little image there. Hate fractions, then get rid of them. That's always our goal when you're solving equations. Get rid of the fractions since we don't like them. So to get rid of the fractions, what you want to do is multiply both sides by preferably the least common denominator, but any common denominator will do. So we want to multiply both sides of the equation by, and I'm going to put the least common denominator. So if we look at 4 and 6, the smallest number that goes into both, that 4 and 6 both go into, is 12. So that's going to be our least common denominator. So that means I'm going to multiply both the left side and the right side of my equation by 12. And remember, the reason why we're doing this is because it's going to cause our fractions to drop out. Okay, so if we look at the left side, remember 12 is really over 1, so it's in our numerator. We can cancel out that 4 with the 12. 4 can go into 12 3 times. 4 can go into 4 once. So we're left with a 3 in the top. On the right side, 6 can go into 12 2 times. So we'll have a 2 in the top, left with a 1 in the bottom. So now I'm left with a 3 times 3x plus 1. Since 3 is being multiplied by all of that, make sure to have your parentheses there. And on the right side, we're left with 2x. Okay, so now that we have our parentheses, we need to use the distributive property and multiply the 3 times everything in the parentheses. So we have a 9x plus 3 is equal to 2x. To get my variables together, the quickest way would be to move all of my variables to the right side, so that way my number will be isolated. So I'm going to subtract 9x from both sides. Okay, so I'll have 3 is equal to a negative 7x. So now to isolate the x, the opposite of multiplying by negative 7 is dividing by negative 7. Okay, so we have our final answer that x is equal to a negative 3/7. Remember, with a fraction, it doesn't matter if you pair the negative with the top or bottom. Typically it's paired with the top. But again, they're both equivalent. Okay, for part D, okay, we have an equation involving decimals. So you can solve this the same way that we were doing the other equations. We can start by subtracting 0.5 from both sides to get the x's together. So minus 0.5x and another minus 0.5x. Okay, so the 0.5x's cancel and we're left with a negative 2 on the left, bringing down our equal sign. 1.19 minus 0.5. Just get your calculator out if you need to. That's going to leave us with a positive 0.69x. Then our last step is to divide both sides by 0.69 because we're trying to isolate our x. So we have x is equal to negative 2 over 0.69. Now we don't want to combine decimals and fractions, so what we can do to get rid of the decimal value of 0.69 is we can multiply both the top and the bottom by 100 because that would remove the decimal. Okay, so if I multiply both the top and the bottom by 100, so that's not changing it, right, because 100 over 100 is just equal to 1. That'll give us an answer of negative 200 over 69. Okay. Well, there's another way that you can solve this problem. Similar to the last one where we wanted to get rid of the fractions as the first step, if you don't like dealing with decimals, we can get rid of the decimals as the first step. So first you want to look to see what is the largest number of decimal places that we have, and we see that it's 2. So since there are 2 decimal places, that means we need to multiply by 100 to get rid of the decimal. Okay, so let me put this alternative method down here. Okay, so and I'm going to start by multiplying both sides of the equation by 100. So we have 100 times 0.5x minus 2 is equal to, and then we're also doing 100 times 1.19x. So on the left, we need to make sure that we're distributing that 100. So that'll give us a 50x minus 200 is equal to, when you multiply 1.19x by 100, that gives us 119x. So now I subtract 50x from both sides, so I can combine my like terms. So we now have negative 200 is equal to 119 minus 50 is 69, so we have a 69x. Then our last step is to divide both sides by 69. And notice that we still come up with the same result. X is equal to negative 200 over 69. Okay, moving on to page 2. Okay, we have a couple more examples, and it looks like this should be an E and an F. Okay, so for part E, we want to solve this linear equation. So hopefully the first thing you recognize is that on the right, we need to go ahead and do that multiplication so we can get rid of our parentheses. So the left is staying the same at 4 plus 2x. On the right, we end up with a 2x plus 4. Okay, well now, let's say that I want to get my variables to the left side. Well, we have a 2x on either side of our equation, so that means we're going to just subtract 2x from both sides. However, when we do that, notice we're left with 4 is equal to 4. There's no variable left to solve. Well, 4 equals 4 is always true, right? Whenever you have a number equal to itself, that's always going to be true. So if you end up with a result like that, what that means is that all real numbers are a solution to your equation. So our answer would be all real numbers. What that means is any number you pick, for example, if you picked x equals 7, if you plug that into your original equation, you're going to find that the equation is true. Both sides will be equal. If you pick x equals -5/3, it's also going to be true because our solution is all real numbers. And that's because we ended up with a statement that's always true. Okay, well, for part F, to solve this one, on the right side, notice we have like terms, 10x minus 7x, so we need to combine those. So first, bring down our 3x plus 7, since we're not working with it yet. 10x minus 7x gives us 3x, and we still have plus 1. All right, so notice we have a similar situation that we had with the last problem, because we have exactly the same variable on either side of our equation. So when we subtract 3x from both sides, okay, the variable 3x drops out, and we're left with 7 is equal to, and then we have a 1 on the right side. Well, 7 does not equal 1. That's a false statement. So when you're simplifying an equation and you end up with something that's false, that means that there is no real solution. There's no number that you can plug into x that's going to make that equation equal or make that equation true. Okay, so next we're going to look at solving basic rational equations. A rational equation is any equation that contains fractions with variables in the denominator. So remember our little picture here, hate fractions, then we want to get rid of them. So that's going to be our strategy when solving rational equations, kind of like you saw on the last page. So these are our steps to solving a rational equation. First, we want to factor the denominator, if applicable. Secondly, we want to get rid of the fractions. So we're going to do that by multiplying both sides by a common denominator. So as I mentioned before, the least common denominator is preferable, but if you have trouble figuring out what the least common denominator is, you can always get a common denominator by multiplying every denominator that appears together. Okay, and I'll mention that again in just a moment. Okay, so once you multiply both sides by the common denominator, that makes your fractions cancel out and you need to solve the resulting equation. Now this part is different from linear equations. We want to check our answer in the original equation once you come out with one, because when you multiply both sides of an equation by a variable, extraneous solutions may result. That means you may come up with the final answer, but it won't work when you plug it back into the original. So checking your work is key. You don't want to skip that step with rational equations. Okay, so my little hint here, to find a common denominator, every denominator should appear as a factor at least once in the common denominator. Okay, so we're going to keep that rule of thumb in mind. So the first example, we want to solve this rational equation. Well, we only have one denominator, and that's x, so that makes our work easy. So I need to multiply both sides of my equation by x. So on the left, remember you can think of x as being over 1. So we see that the x's cancel out, and we're just left with 4 over 1, or 4. The right side, we just have a 5x. So now we're ready to solve. Our last step is to divide both sides by 5. And we end up with x is equal to 4 over 5. Okay, so remember, we should not just accept that as our answer just yet. We have to do that last step and check our work and make sure that this is not an extraneous solution. So if you end up with a fraction for your answer and you need to check it, if you can simplify that fraction to a decimal, an exact decimal, then it's sometimes easier to plug the decimal value in to check it. So if you do 4 divided by 5, that's actually equal to 0.8. So I'm going to plug 0.8 into my equation because it just makes it easier in the calculator. So we're checking if 4 divided by x, so 4 divided by 0.8, does that equal 5? So I put a little question mark over the equals because that's what we're trying to figure out. Well, in your calculator, if you do 4 divided by 0.8, you'll see that it does in fact equal 5. Therefore, x equals 4/5 is our answer. So in math, unless you're dealing with an application or otherwise stated, having your answer as a fraction in lowest form is preferable as opposed to the decimal. Okay, and you never want to round your answer unless the problem tells you to. All right, going on to our second example. Okay, remember our first step in solving rational equations is to factor the denominators if applicable. In this one, it is applicable that 4w minus 8 can be factored. We can take a 4 out of both of those terms. So if we factor out a 4, we're left with w minus 2. So now when I look at the denominators I have, 4 times w minus 2 and w minus 2, it's easier for me to see that, in fact, my least common denominator is going to be 4 times w minus 2. Because notice we have every factor appearing at least once. Okay? So now that's what I need to multiply both sides of my equation by. Now on my left, since I have two terms, I'm just going to write my 4 times w minus 2 times each of those. So that'll save us a step from having to write out the distributive property. So 4 times w minus 2 times 8 over 4 times w minus 2. Then we have a minus. We're multiplying 4 times w minus 2 times that term also. So that's times the 1 equals, and now we need our 4 times w minus 2 times the fraction that we started out with, 2 over w minus 2. All right, so now we need to cancel out what we can, because that's our whole point of multiplying by a denominator, is because it's going to make our fractions cancel out. So the 4 times w minus 2 cancels completely in that first fraction, and we're just left with 8. Okay, in our second term, we don't have any fractions, so we have 4 times w minus 2 times 1. So 1 times anything is itself, so we have that negative 4 times w minus 2. On the right side, the w minus 2's cancel, and we're left with an 8. Okay, so now we're ready to simplify. Make sure you distribute the negative 4 to get rid of your parentheses, and we end up with 8 minus 4w. Negative 4 times negative 2 is a positive 8, equal to 8. Okay, so now we have our linear equation, so we need to combine the like terms on the left. So we have 8 plus 8, which is 16, minus 4w is equal to 8. I'm going to subtract 16 from both sides. And I have negative 4w is equal to negative 8. So now my last step is to divide both sides by negative 4. Okay, so it makes our negative 4's cancel, and we have w is equal to 2. Now since we're dealing with rational equations, remember, don't just accept that 2 as an answer, you have to check it. Let's give ourselves a little bit more room there. and you're always checking it back in the original equation. So I have 8 divided by 4 times 2 minus 8 minus 1 is equal to 2 divided by 2 minus 2. Well, I'm seeing what's going to happen when I simplify my denominator. I'm going to end up with 0 in the denominator. As soon as you have 0 in any denominator, you can stop, because if you put that in your calculator, 8 divided by 0, you'll see that you get an error. That's because you cannot divide by 0. That's undefined. So since we end up dividing by 0 when we plug 2 into our equation, that means 2 cannot be a solution. It is not a solution. It would be called an extraneous solution. So our answer for this one is that there is no real solution. Okay, so notice that the W equals 2 is not the answer. The final answer is no real solution. Okay, and I can guarantee you on a multiple choice test, they would have 2 as one of the answer choices. So this is just a good illustration to make sure you check your answer before giving your final answer.